Hi everyone, in this video I am going to explain about the digital comparator. Digital comparator is nothing but is a circuit which compares the two inputs, So it is a digital circuit used to compare two input numbers. We can write these two as numbers, not bits, because these two numbers, let it be a comma b, must be of any size. That means a may be of n bit size like an minus 1, an minus 2 and so on. Sorry, an is not there. An minus 1, an minus 2 and so on, a1, a0, that is of n bit number. And similarly b is also a size of n bit, n minus 1, n minus 2 and so on, b1, b0, it is also of n bit size. So a comparator is a circuit which compares the two incoming numbers a and b, and what is the output after comparison? So when suppose a and b are the inputs for a comparator, when these two are compared, what could be the possible outcomes? So there are three possible outcomes for any comparator. One is a less than b, or a equal to b, or it may be a greater than b. These are the three possible outcomes when you compare two numbers. Okay, it is a comparator. Okay, suppose if you are taking a is of a single bit number and b is also a single bit number, then they may be a, b and a equal to b, a less than b and a greater than b. These are the three possible outcomes. So it may be 0 0 or 0 1 or 1 1 1 0 and 1 1. So 0 0 1 1, what do you mean by 0 0 and 1 1? A equal to b. So in that case a equal to b is 1 and remaining are zeros. That means this condition is a equal to b. And if you look at the second case, a equal to 0 and b equal to 1, a equal to 0 and b equal to 1, it means a is less than b. A is less than b, the corresponding output will be 1 and remaining are zeros. And similarly here a equal to 1 and b equal to 0 means a is greater than b. So a is greater than b1 and remaining are zeros. This is what the output of a simple comparator with 1 bit. Simple comparator of size 1 bit. Okay, suppose if you go to 2 bits, 4 bits, like that, if you are going to n number of bits, then the comparator will be having different complex size. Okay, so in this particular concept we are going to study about two basic comparators, very important. One is 2-bit comparator, and the second one is 4-bit comparator. 2-bit comparator and 4-bit comparator. So 2-bit comparator means what are the inputs for a comparator? A1 A0, and B1 B0. These are the two inputs for the comparator. And similarly for 4-bit comparator means A3, A2, A1, A0. This is first number, and the second number is having B3, B2, B1, B0. This is the second number input bits. Once these two are compared, the output is always only 3, a less than b, greater than b, and a equal to b. Okay, suppose when we are going for more than 1 bit like 2-bit or 4-bit, you should take the number, what could be the total number represented, and we need to compare. Okay, so what A0 and A1 gives you the total number, and what B0 and B1 gives you the total number. For that corresponding total numbers we should compare, not individually. Hope you understand what I am saying. Okay, so first let us start the first one, 2-bit comparator. 2-bit comparator. So as I said, 2-bit comparator has 2 bits in A and as well as 2 bits in B. So this is A0, B0, A1, B1. So outputs are 3 outputs: A greater than B, A equal to B, A less than B. So this is 2-bit comparator. 2-bit comparator. Okay. Now first we should go for the truth table and then K maps and then K maps. Later if you want you can go for the circuit realization also. So the first step is steps to study 2-bit comparator. Okay, first one is block representation. That is what we have done now, representation. And the second one is truth table. Truth table is very easy and important also, because from that only we go for the K map. Truth table. And third one is K map to get the Boolean expression. And the last one is circuit diagram, gate level diagram. Gate level diagram is optional. If you want you can go, otherwise you can skip that and directly you can go to the programming. And the last one is VHDL code. These are the steps, important steps you should study when you are going for the 2-bit comparator. Okay, so the first one is over. The second one is truth table. So truth table, input bits are A, B. So A consists of 2 bits, A1, A0, and B also has 2 bits, B1, B0. And the outputs are now A greater than B, A equal to B, A less than B. For any comparator, these 3 outputs are common irrespective of the size of the input number. Now let us think these 4 are 4 input bits, and so that 4 zeros to 4 ones, the combinations will be going on. So 0 0 0 0 0 0 0 1 1 0 1 1, and next 0 1 0 0 0 1 1 0 1 1, 0 1 0 1 0 1. Okay, and next 1 0 0 0, this is A1 A0, B1 B0. So 1 0 0 1 1 0 1 1 1 0, and similarly 1 1 0 0 0 1 1 0 1 1. So 1 1 1 1 1 1. Now let us see how the output is going to be written. A greater than B, A equal to B, A less than B. See here, the number corresponding to this 0 0 is 0. Okay, I will take a different color to represent the corresponding binary equivalent, decimal equivalent. 0, this is also 0 0, here it is 0, here it is 1 1 1 1. Okay, for first 4 numbers A is 0 and the next 4 is having A is 1, and similarly here B is 0, this is 1, this is 2, and this is 3, and similarly 0 1 2 3. This process is repeated, this number is repeated. This is 1 here, and this is, sorry, this is 2 and this is 3. and here it is 0 1 2 3 0 1 2 3. Okay, that means the binary equivalent for this one is here. Hope you understand what I am trying to say. Okay, and similarly this value is equal to 3. Similarly this value is equal to 2. Okay, now compare the decimal numbers 0 0. 0 0 means a equal to b, so a equal to b is 1 and remaining are zeros. And similarly okay, remaining are zeros. And similarly 0 and here it is 1, so 0 1 means a less than b, it is a less than b, next one is also a less than b, next is also a less than b. 0 0 0 0 and this is also 0 0. Next it is 1 and it is 0, so 1 0 means a greater than b, so this is 1 and remaining are zeros. Next a equal to b, next two are a less than b, and similarly here also 2 0 means a greater than b, it is also a greater than b, and it is a equal to b, and it is a less than b. Here 0 0 0 0 0, here it is 0 0 0. Next 3 0, a greater than b, it is also a greater than b, it is also a greater than b, and it is a equal to b. Okay, so for 4-bit number also you should do the same. Okay, first you have to take the corresponding decimal equivalent of the binary representation of a and as well as b. Later you should compare a and b. You should compare a and b. Suppose if you are familiar with this particular representation, directly you can do that, no problem, no need to go for the representation in the decimal format. Okay, directly you can represent 1 0 means 2 and 0 0 means 0, so directly you can write it as a greater than b. Okay, if you are not much familiar, you can just represent roughly at somewhere, and later you can go for the representation. Now we need to take 3 k maps, those 3 k maps for a greater than b, a less than b, and a equal to b. Okay. So that we will see in the next coming video. Okay, thank you.